All right, so we are going to look a little bit more at what happens when we have an equation with two variables and what solutions we have for these equations. So let's take an easy one. X plus y equals 4. Okay. Well, what's the solution? If I have like 2x equals 4, how many solutions does this have? This only has one solution. There's only one solution that works. I'm going to divide both sides by 2, divide both sides by 2. X equals 2, period. X does not equal 7. X does not equal 4,064, right? Like X doesn't equal any of those things. X equals 2. Well, what does X equal over here? What does Y equal? How do we find out? So let me tell you something. X could be anything. X could be anything in the world. But once we decide what X is, we're stuck with what Y is. But Y could be anything in the world. But once we decide what Y is, we're stuck with what X is. Let me show you what I mean. Let's pretend that X equals 2. I liked X being 2 over here. X can be 2 over here. So if X is 2, I'm going to substitute this 2 in for X, right? Right there. And so I'm going to say, instead of saying X plus Y equals 4, I'm going to say 2 plus Y equals 4, because we just said that X equals 2. 2 plus Y equals 4. Well, can Y be anything in the world now? Nope. Y is stuck. So I'm going to subtract 2 from both sides. Oops, not from that side, from this side. And Y is 2. Period and end of story. So our solution is X is 2 and Y is 2. But is that the only solution? No, it is not the only solution. What if X over here, I said X could not be 7. What if I want X to be 7 over here? Could X be 7? Oops. Let's see. Could X be 7? Sure. Why not? Let's make X 7. So now instead of X being 2, like it was a second ago, X is 7. Can X be 7? Sure. Let's see. So instead of X plus Y equals 4, I now have 7 plus Y equals 4. Why? Because X is 7. We said so. So if X is 7, then what does Y equal? Well, can we solve for Y? Yes. Yes, we can solve for Y. So I'm going to subtract 7 from both sides. Remember, I've got to do it. If I don't do it, then it's crap. So subtract what? Ooh, it's a negative number. Is that okay? Sure, it's okay. Negative numbers are numbers too. Okay, so 4 minus 7 is negative 3. So does this work? If X is 7, okay, 7 plus negative 3, 7 plus negative 3, 4. Yes, it works. Is this a solution? Yes, it's a solution. Wait, whoa. So we have more than one solution. Comma negative 3. Could X be 4,064? Why not? Let's do it. So let's say that X equals 4,064. Is this okay? Is this allowed? Wait, what? But what? But it has to add to Y to equal 4. And what? Let's try it. Let's do it. Let's substitute it in. So I have 4,064 plus Y equals 4. All right. Can I solve for Y? I can solve for Y. Subtract 4,064. I'm having some big number regret here, but that's okay. 4,064. And I end up with Y equals negative 4,060. Can Y be negative 4,060? But I thought we said that Y is 2. And here we said that Y is negative 3. Okay, yeah. Y is negative 3 when X is 7. Y is 2 when X is 2. Y is negative 4,060 when X is positive 4,064. Y depends on X. because y is the dependent variable most of the time. Now, does that mean that I can only substitute in for x? No, I can totally substitute in for y too. I know that x plus y equals 4, so could I say that, hey, what happens when y equals 1? Or what happens when y equals -3? Let's see. What happens? Well, yeah, what happens when y equals -3? I know that x plus y is 4, so x plus -3 equals 4. So I can either subtract -3 from both sides because this is a plus, or I can recognize this and go, hey, well, adding a negative is just the same as subtracting, so I'm going to add 3 to both sides. Subtracting a negative is the same as adding, so it works. So I'm going to do plus 3 to both sides, plus 3 to both sides. And x is 7. So when x is 7, y is -3. No, wait, when y is -3, x is 7. And when x is 7, y is -3. That's a clue that we did it right if they equal each other. Should we do another one? What if I have another one? What if I have 2x minus y equals 6? What's the solution? Because there's going to be a whole lot of solutions. In fact, there are infinitely many solutions. There are as many solutions as there are in the universe, and as there are numbers in the universe, and there are a whole heck of a lot of numbers in the universe. Could I put fractions in? Sure. What if x equals 1/2? Is a fraction a number? Fractions are numbers too. People don't like fractions, and it kind of makes the fractions feel bad because fractions care. It's not their fault. They're not a whole number, right? So let's do it. So 2 times 1/2 minus y equals 6. Can I solve for y? Yeah, I can totally do this. 2 times 1/2 is 1. That was awfully convenient. I may have chosen this on purpose. 1 minus y equals 6. So I've got this 1 is added. So I'm going to subtract it from both sides. And I have negative y equals 5. Well, this is all well and good, but I don't care what negative y equals. I care what positive y equals. So I have kind of an invisible little -1 there. So if I can multiply this side times -1, and I can multiply this side times -1, right? And then I can get rid of this negative. Okay, so y equals -5. Does this work? Yeah, because 1 minus a -5 is positive 6. So my solution is 1/2, comma, -5. And what we end up getting is we're actually going to get a whole millions and trillions of points. Let's do one more on this one with substituting. We'll have x equal 7. Why not? Oh, x was 7 up here. Apparently I like the number 7. Okay. So 2, actually don't like number 7, but whatever. 2 times 7 minus y equals 6. Can I solve for y? I can solve for y. I can do this math. 14 minus y equals 6. Subtract 14 from both sides, right? Because it's plus 14, got to subtract it. Okay, so now we have negative y equals a -8. Well, if negative y is -8, then positive y is positive 8. I don't even have to multiply out that way because I can just do that. So my solution is 7, 8. When x is 7, y is 8. And let's double check this. 2 times 7 is 14, minus 8 is 6. It worked. Okay, so let's do one down here, and we're going to have a little bit of a twist with it. Uh-oh. We're supposed to have a coordinate plane on this one. And we don't have the coordinate plane. So let's see what's going on here and why I don't have a coordinate plane. I'm going to actually open a new Kami window. And I'm going to go grab your assignment. Open from Google Drive. Let's grab your assignment here. And it should have there we go. There's the coordinate plane. Okay, so it shows up on your assignment. That's good because you kind of need that. I don't know why it didn't show up on the other one. Okay, so we're going to find 5 solutions, and then we're going to plot the solutions as points on a coordinate plane, and we're going to see something about these points. So so we know that x plus y equals 3. Okay, this is very, very similar to what we did before. So let's pretend, I'm going to actually make it a little bit easier. What if x is 0? Then what's y? Let's find out. So we have 0 plus y equals 3. Well, y equals 3. Boom. What if x is 1? I have 1 plus y equals 3. I'm going to subtract 1 from both sides, subtract 1 from both sides, y equals 2. Okay. What if x equals 3? So we have 3 plus y equals 3. Okay, so I'm going to subtract 3 from both sides, subtract 3. Oh, subtracting from the same side. Don't do that. That's a bad thing. So y equals, well, 3 minus 3 is 0. So y equals 0. Okay. So let's say that x equals 5. Could we do that? 5 plus y equals 3. How do I solve for y? I subtract 5, and this isn't a whole lot of room for you guys to work, so you can spread out and work a little bit more on your page. So we have y equals, well, 3 minus 5 is negative 2. So y equals negative 2. Can y be negative? Sure, negative numbers are numbers too, and we care about and we love them. And let's pretend, okay, should we make it x a negative number? Why not? Let's do it. Let's make x negative 4. Do you need to do negative numbers on your assignments? No, but I'm choosing to do a negative on mine because I want to. So you don't have to. So negative 4, if x is negative 4 plus y equals 3. So I'm going to add 4 to both sides because this is negative, so I have to add. And y equals 7. All right, so now we're going to plot these solutions because if x is 0, then y is 3. So x is 0 and y is 3. 1, 2, 3. And then I make a dot right there. Okay. If x is 1, y is 2. 1, 2. Bloop. If x is 3, then y is 0. Okay. What about if x is 5? Then y is, oh, negative 2. 1, 2. What about if x is negative 4? Then y is 7. Clear up here. All right, and remember, what kind of equation is this? It is a, no, I want to do this kind of highlighter. It's a linear equation. I ended up highlighting like way more than I intended to. Sorry about that. But it's a linear equation, right? Okay, make that menu go away. Linear means it's in a straight line. Are these all in a straight line? Yes. And are there only 5 solutions to this? No. Let me show you what I'm going to do. I'm going to graph all the solutions of this thing because it's not just those guys. It is all of these points. And actually, this line could keep going forever and ever. Now, they all lie on that line. If I had some random point out like this, guess what that would mean? That would mean I made a mistake. But I did not make any mistakes, and so I don't have a random point out there. Whoa! Oh, that was bad. Oh, goodness. Don't try to erase on your thing. Woo! Okay, that's good to know. It erases. Don't erase your coordinate plane. So, but if you look, everything is on a line. So is this a solution? Yes, even though it's in the middle of 2 points, and I really couldn't tell you what that number is. It's like negative 2.5 and positive 4.5 ish, somewhere in there, and I can't really tell, but that's a line. So this whole line is the solution, not just these random 5 points that we chose. We chose the random 5 points so we could see where to connect the dots. Okay. So there you have it. Now the rest of these are for you to do. So this one, the coordinate plane was below the box, and yours on this next one, the coordinate plane is above the box, because what I actually did is I went through and I added the coordinate plane. I erased this bottom one, added the coordinate plane in underneath. And then I erased the top one and added the coordinate plane on top. And I erased a problem down here and added the coordinate plane. And then I did that for all of them. So you guys would have a coordinate plane. When I was your age, back in the olden days, before the times of the computers, I had to draw my own dumb coordinate planes. So just be aware that I love you and I'm giving you guys coordinate planes so you don't have to draw them by hand, because that would be kind of a sneak. Can we do this with fractions? Yeah, we can do this with fractions. So have at it. I kind of enjoy this stuff because you can just play with it. X can be whatever you want. Now, here's the problem though. Okay. So like, remember in an example, we said that like X was like 4064 or something huge like that. So you will have a challenging time graphing X is 4064 on my coordinate plane that only goes up to 10. So if you really want X to be 4064, you've got to come up with your own coordinate plane to accommodate it, because it still needs to be on your graph. So consider that, and maybe don't have X be 4064 unless you want to have like an enormous coordinate plane, which you are welcome to do. Go crazy with it. Let me know if you have any questions. This stuff is enjoyable. I like it. It's kind of fun to just kind of play with it, and you don't have a tremendously huge number of problems. You have this one that I did for you. And then 1, 2, 3, 4 that you use. It's not too bad. Anyway, enjoy. Have fun. Bye.